Hello everyone! I've gotten a few emails about this week's lab, so I thought I'd go ahead and make a tutorial video since we can't meet in person. I don't have a printer, so hopefully this little drawing will do for now. We're going to go over chapter 6, Topo Maps. We use topo maps to read large-scale 3D landscapes in a convenient 2D way. So first of all, it's important to note that any green on the map is going to be vegetation, blue is going to be water, red or black is cultural features, and brown is grid and contour lines. So going ahead and looking at this little map, for an example, this part's blue, so you can automatically tell, hopefully, that this is some sort of lake. I'm going to show you guys how to measure at home since you don't have an accurate scale map in front of you, and some of you might not have a ruler. So this is going to be the easiest way to take measurements. First of all, this is going to be the scale that we have on this map. If I ask you to measure the distance across from this lake, you're simply just going to put a tick mark on each side. So that's the diameter of the lake, right? And then you're going to go over here to your scale. So start at 0. For me, I like to put a little mark here, so I know that's 1, and this is the remainder that we need to measure. I'm going to come over here, so it's 1.2, and it's in miles. So we know that the diameter of this lake is 1.2 miles. Okay, easy enough, right? And that's just with using paper, no rulers required. Most fractional scales on your maps are going to be 1 to 24,000, and that's unitless, but we'll get to that later. And I was just going to show you guys, if you're confused about how these lines add up, we'll just go ahead and draw them out. So let's just say we want to measure this part of our little island. Saying that this starts at 0 to this side, which is also 0. And this is our line. And the contour intervals are going to go by 10. So right here, we have 10, 20, 30, 40. And these lines right here at the tick marks, that indicates going down. But the first one is going to be the same elevation, so that's going to be another 40. All right, sorry to skip ahead. A telemarketer just called me and it interrupted my video. So I went ahead and finished drawing this. So as you can see, we stopped at this point or this point. So this point was 30. And we're gonna dip a little bit below because this more than likely isn't gonna be flat across the bottom. It's gonna be a little bit lower. And then we're gonna come back up to 30, 40, and then it's 40 again. And it's also going to dip a little bit up because that's probably not a flat surface either. We will see some flat surfaces in later labs, but for now we can assume that it's probably not flat. And then we're gonna go back downhill by the same intervals of 10. So this is your 3D surface. If you were standing at point 1 and point 2, you wouldn't be able to see each other at other sides, right? Because you're going to have a big mountain or hill in front of you. Moving on. This scale down here, earlier I mentioned the 1 to 24,000 scale, which most maps will have in person. I don't know if it'll continue to be that way throughout the remainder of the online labs, but this is just an example. So this tells you if you measure something on a map, 1 of that unit is going to be equal to 15,840 of the same unit. So if you were to measure 1 inch, it's the same as that amount of inches in real world distance. but they're wanting you to convert it to miles. So if you measure 1 inch on the map and it's equal to 15,840 inches, then you're going to convert inches to miles. And so I'll go ahead and write it here. So y'all should probably go ahead and note that 1 mile is 63,360 inches. And then you can go ahead and look up miles to feet. You should probably know what inches to feet is for the rest of these calculations. Okay, then we turn to the next page. We're going over meridians and parallels. Meridians is going to be degrees of longitude, and parallels are going to be degrees of latitude. So for example, this dot over here, you're going to have your equator and your prime meridian, and above your equator is going to be north, and below is going to be south. And then the same with the prime meridian. It's going to be to the west or to the east. So if you have a point over here, starting with your latitude, you're going to have 20 degrees north, and then go over 45 degrees west. And that's how we do coordinate systems. Between the degrees of longitude and latitude, we're also going to measure by minutes and seconds. So for example, on a map, if you are looking for this spot right here, on the sides of your map, you see you have your degrees on each side. So if we're looking for the latitude, it's going to be 4 degrees. And then 1 tick mark means minutes and 2 means seconds. So it's going to be about going down 32 minutes. And it's right in between these two, so we'll say 30 seconds. And it's south because it's counting downwards, so you're going south, okay? Going this way. And then for your longitude, if that's your prime meridian, and we're going this way, then it's going to be west. So it's going to be 0 degrees, 2 minutes, 30 seconds west. Does that make sense? We're also going to go over township grid system, but I do not think you guys will have to know this for lab since you don't have the overlays at home. There's no way you can really work with this material without having those overlays. So this is super accurate because it goes by these squares, and each square is divided into even smaller squares, and you can go on an infinite amount of times and pinpoint like a blade of grass on the earth where exactly that's located. So this, you're going to have your sections, and it's going to have your directions, your ranges, and your townships. And you can locate that because if you have here and you go over to 4, and this counting system goes like this. Kind of weird, but really effective. But then you can take your section 4 and you can get 1/4 of that. And then you can take 1/4 of that. And then you can take 1/4 of that, and so on and so forth, an infinite amount of times. Okay, and then we're going to talk about north. You have true north and magnetic north. True north is going to be along a more convenient meridian, one of those degrees of longitude going up to north, which is going to be this little star right here. Magnetic north is actually going to be the true north because the magnetic pole will change with seafloor spreading, and that's going to be what your compass will work with. So if the map was made in a certain year, and then in 1977 they determined that magnetic north was 17 degrees east, then you're going to have a 1977 down here below, and you're going to see that on all of the maps you're working with. Lastly, we're going to talk about contour lines, which we saw with our little example map. Here our contour interval is 200. So starting at each individual contour line, you have 0, 200, 400, 600, 800, 1000. This dark line indicates your index contours, which here is 1,000. And it doesn't seem like that, but if you count, it's 1,200, another 1,200, and back to 1,000, which is another dark line. So these, again, are your depression contours that count downwards, whereas these count upwards. So this will go up, down, and then back up again, going across a profile. I'm not going to work through this part with you guys, but I'll go ahead and reiterate some things, and hopefully you can work on it by yourself, and when you turn in your labs I can provide some feedback. So the fractional scale of this map, most of these answers are given to you right here. So that says scale. And the reason it's this number instead of the other numbers I was talking about earlier is because of the size of this map on this paper and how that affects real world distance. Okay, the contour interval is given to you over here. Magnetic declination. So remember we talked about which direction that's going in, and then it says a year. And then when it talks about latitude and longitude on the next page, remember we have our degrees down here. Remember to pay attention to which direction it's counting in. And don't forget to write your tick marks for minutes and seconds. And then again on this side. And then real quick, we'll go over steepness. So don't forget about this guy. If you need to, on a separate piece of paper, to take this map and do something like this to it, so you can tell if you can see someone if you're standing here and here, or here and here. This will help you a lot in these beginning stages. Okay, so steepness, something is a lot steeper when the lines are closer together, and it's not as steep when they're far apart. So like this part would be a lot steeper than the rest of it. And then map relief. So you're going to take your highest contour interval and your lowest, which is going to be down here. It's probably 0, sea level. And you're going to subtract the 2, and that's going to give you your relief over the whole map. And if you're not quite sure on a number, say if something's right in between 1 and 5, but you don't want to put 2.5 or 3, you can write the 3. But if it's 2.5 or 3.5, you can put plus or minus 0.5. And that will give you your most accurate answer for this lab, okay? All right, well, y'all have a great rest of your week, and let me know if you'd like to Zoom, and I will see you soon. Good luck.